This is part 2 to the Olympic Model 6-606 vacuum tube radio that can be run off batteries, AC or DC, from 1946. You know, the one with the curtain burner cord. So we've got the tube tester here. We're going to test the tubes and we're going to see if we can get this one working and see how it performs. For those that haven't seen part 1, I'm going to give you a bit of a refresher here. It's not going to be long. We're going to do a bit of a refresher and then we'll get right into part 2. This is my latest find off Facebook, and I actually paid a little more than this than I usually do. I paid $30 for this one, but I think that for $30 I did okay. This one's using a 35Z5 rectifier, but these tubes are a 1LN5, a 1LA6, a 1LN5, a 1LH4, and a 1B4. So the filaments are all 1 volt rated. Actually, they're 1.5 volt filaments, but they just put a 1. I don't think I've ever seen one that uses 1 volt rated filament tubes. Before I even get into the radio, let's take a look at the schematic, because this is different than most of these other radios that you would encounter, like the AA5, which of course have all the filaments in series, and you know the 12 volt filaments add up to 120 volts. In this case, the only filament that's actually powered from well, I guess they're all powered from AC when you're running off AC, but because this one can run off DC, you have a separate supply. So we got a few capacitors to change in this one. Here's the bottom of the unit. We're going to change out all these paper caps that are on here. We're going to do that first, and I'll put a new AC cord on this unit. Oh, what is this? Well, this is the most dangerous part of this radio. The resistor cord. Odd looking AC cord. Talking about a fire hazard. Look at this AC cord. Besides it being all tattered and worn, it actually has a wire around the outside of it. It's a resistor. It's not just a conductor. There's actually a resistor on here that is used as a resistor for the filament, for the rectifier tube. This one's a 0.1. Just cut this one out of the circuit. Get the new one in place. I'm going to leave it right now. We're going to jump ahead to part 2, because if you've watched part 1, you know that it doesn't work at the end of part 1. So we're going to come back. I got a tube tester. We're going to find out why it's not working and see if we can get it to work. So let's fast forward to part 2. So I'm back on the little radio that had the curtain burner cord on it. I got my buddy's tube tester. We're going to go through and test the tubes and see whether any of the tubes are bad, and then we'll see whether if the tubes are good, then I'll proceed to start to troubleshoot some more things. But if we got a bad tube, then I'm going to have to go back to square one and try to find a replacement tube. So we'll start out, we'll work our way across and test all the tubes out. So let me just bring up the tube tester, put that up on the bench. My buddy bought this for $50. I'd give him $50 for it. It's got a price tag still on it. I'd give him $50 in a heartbeat for this thing. Alright, so let's start. We'll pull out the first tube here. Let's check well, we know the rectifier works, but we'll check it anyway. So this tube is what is this one? A 35Y4 or 35Y5? What is this thing? 35Z5. So what we do is we look up the tube. Z5. Here it is down here. It goes into, we select I, and we use socket 11, and we select the load to 26. So we select this to I. We set the load to 26. And we use socket number 11. And I just have to power this thing up. let the tube warm up, and then it'll tell me if it's any good. Okay, the tube is warmed up. To test it, we see that there's no gas and there's no short, so we test it. We'll see that this tube is off the end of the scale. This tube is good. We knew that because we've got DC. So I'll replace this tube, and we'll go to the next one. Gotta be careful pulling these tubes out. I don't want to drop one. This one is called a 1LB4. I'm just going to use a 1-volt filament. 1LB4. It's selectors number A, socket number, or load 47, and socket number 29. So socket 29 is this one right here. Just rotate the tube until it goes down, and then we're going to select the load to 47. Let the tube warm up, and we'll see what happens. I think this tube is dead. That's what I thought. I thought it was probably going to be the audio output. This is the audio output tube. I kind of figured it was the audio output because when I applied an external signal to the grid, I got nothing. So I was kind of sure it was going to be this tube. If any of them were shot, it was going to be this one. And it looks like that's the tube that it is. We will test the rest of the tubes, and then I'm going to have to try and find one of these ones. But as you can see, oh, wait a minute, it just came on. Well, what the heck happened there? Oh, yeah, you gotta shorten it or something. See that? Now it's testing good. Yeah, that the tube tester's not working properly. That's a possibility too. Could be the switch. But now this tube is testing good. The next one's at 1LH4. So 1LH4. Selector A, load is 49, socket 29. That tube is testing good. So it could be that it could have been the that output tube was acting up, and now it's decided it's going to start to work. We'll test all the tubes, and then I'll plug this radio in and see whether we get any sound out of it now. This one's a 1LN5, 47, and socket 29. Looks like these use a lot of the same settings. Now it's testing good right away. I take it that these 1-volt filament cathodes heat up pretty quick. I'll unplug it. We'll just see. I'll plug it in and see how fast this thing comes up. So power, yeah, they heat up pretty quick. That tube doesn't even want to come out. Don't want to put too much pressure on it because I don't want to break it. Nothing worse than breaking a vacuum tube and getting shards of glass into your fingers. This one's another 1LA6. So 54, again on socket. This one's socket 28. So setting is 54. And that one's also good. This is the last one, and it's also testing good, a 1LN5. So let's power this radio up again and see if we get anything different happening with it now. Now that this tube is working. But we clearly saw on the tube tester when I first put it on until I give it a tap, it was bad. So let's try the radio now. To be clear, I don't think that tapping the tube fixed it. I think the problem was the tube tester. The test button, the switch, wasn't working, and after I activated it a few times, it fixed it. Because if you saw when it first popped up, I hadn't touched the tube. I was holding the button down, and all of a sudden the meter started to jump a bit. So I think that the problem was not the tube, it was the tube tester itself. Because it's old as the hills and it hasn't been used in years. So there could have been some oxidation on that test switch. And I think that's why the tube wasn't reading good initially. And tapping it was just a coincidence. Hear nothing. Feel the tube starting to warm up. But we don't get any DC, or we don't get any filaments until this one starts to conduct. So we should be getting filaments warming up. One thing I considered, and I considered this last week, the line cord had a 540 ohm resistor. Now the closest I could get was 680. Now there was another 100 ohm resistor in series with the filaments, which I've removed, which would have made it 640, but I'm at 680, so my heaters are not getting up quite to full temperature, and that might be causing low B+, and that might be my problem. I could add another capacitor to the B+ rectifier, or B+ filter, because I just realized that the one that was in there was actually bigger than what I put in. I should have put two of them in parallel, but I didn't. These are on two different sources. So I actually should have two of these in parallel. So I added another one. This one's more than big enough. This will, when the B+ comes up, this will give me a little more stability. Here we go, B+ is starting to come up now. I'm thinking because the filament voltage is a little bit low to that 35Z5, so the B+ is a little bit low, and because the filaments for the other tubes is derived from the B+, they are not getting hot enough to put the tubes into conduction, and that's why it's not working. My B+ should be about 130 volts, so that's definitely too low. And if that's low, then the voltage across all the filaments will also be low. Now, one of my options on this radio is I can eliminate this rectifier tube and just put a diode across here. Right? That's always an option. You can always just put a diode in place of that 35Z5 rectifier tube. And then it would eliminate having to have this big resistor as well. And that would give me some voltage, for sure. We could do that. We could put just a single diode across there. A single silicon diode will certainly give us some good voltage on the B+. So if I put a 1N4005, which would be plenty, across the tube socket. I'll pull the tube when I do it, but I'm just going to put it across the socket here, which will put it right across with this resistor, I believe. 27 ohm, 10%. Yep, 27 ohm. That's the output from what it looks like here. So I'm on pin number 8, between 8 and 5. looks like. So this is our resistor that's on the plate, cathode, right? Pin number 8, and 5 and 2 are jumpered together. 5 is over here, so 8, 7, 6, 5. 5 is across the 2, which has also got the line cord on it. So we're going to go between pin 5 and I'm going to do between pin 2 and pin 8, just because 2 and 5 are connected together. Put our cathode to the resistor here, right to there, and then the anode down to the next pin over. We'll just put that resistor or this diode right in here. Then I'll pull the tube and we'll just run it as a 5-tube radio without the rectifier tube and see what our B plus comes up to. And I'll bring it up slow on the variac so that I don't blow anything up. So we'll turn the variac way down. Oops, and measure the voltage. That came unsoldered from the tube. It's okay, we can hook it right up to here for our testing purposes. I'll wire this in more permanent if I decide to make it a permanent attachment. But for now, if I can get my wires to stick, get the solder in here to the line cord. And the other side of this diode to this resistor. And I'll pull the tube. I'll pull the rectifier tube. There's no point in leaving that in for this test. Alright, hook up the meter for measuring the voltage. We'll measure it right here on the output of the capacitor, like the output through that resistor. Alright, I'm going to take my variac and I'm going to run it down really low. And we'll plug this unit in and give it power and watch what the voltage does, because the voltage will come on immediately now that it's got a diode in place instead of a vacuum tube rectifier. Okay, power on. Variac is turned right down low. We have 55 volts on it right now. We'll gradually bring this up so that we have about 120. So I've got 130 volts now on the filter capacitor. just want to measure my incoming AC voltage off my variac and see whether I'm at 120. And if I am, that diode's going in permanent, and this is going to become just a solid state rectifier radio. So here's AC voltage. Let's measure our AC voltage going to the radio. So we're actually running at 126. Let me just take my voltage down to 120. Normal voltage. 120 volts AC. Or DC voltage. I have 121 volts.
These guys out the slouch pirates on you.
Let's make this permanent. So the first thing I'm going to do is I'm going to remove the resistor that I put in. We don't need this big load resistor. I'm going to leave the tube in place. I'm not going to like run it without the tube because I want it aesthetically to look the same, but it will be internally disconnected. Remove that. We'll just cut it, remove it. Cut off this other wire down here. That's the wire that goes to the filament. So we don't need the filament. Then the tube can be put back in to the tube socket, and it just won't operate. And then I'm just going to shorten this diode down here, connect it right to the AC line. We'll put some heat shrink tubing on here, going to this resistor, just to make things safe. So let me just undo here from this one. And again here. I know I've just probably upset the purists out there. They're going to get upset, but because, you know, I seem to upset someone every time I do something. I'm going to have some purists screaming at me saying, "You can't do that to a vintage radio. Put a solid state rectifier. What the hell is wrong with you?" Believe me, I've had people do that. They've screamed when I put a solid state rectifier in something. I had somebody whining and complaining when I put a rectifier in series with the Danico to stop the tube from arcing, because of course the newer tubes have a little lower peak reverse voltage. So what we do on the ST70s is add a resistor in series, or add a diode in series with the tube. Tube rectifier is still there; it's still in operation. But we just put a diode in series with it, so that it's not seeing AC anymore. It's only seeing the rectified, already DC rectified, still going through the rectifier tube. So it's not like you're going to lose any sound quality. It's just done to protect the tube. But some people don't like that. It's like they don't understand. So here we go. This one's now connected. The filament for the tube is completely disconnected. I've got some heat shrink tubing on here to protect, so nothing's going to short. I don't even need to heat shrink it. It already heat shrinked when I soldered it in place. But now I can drop this tube back in. This tube will just be there for show. It's not going to perform any function. but it now looks complete. When I power the radio up, sound should come on actually quite quick because these 1 volt filament tubes actually heat up fairly quick. So when I turn this thing on, we'll get sound on this thing really quick.
Hi, Evan. How are you? Wow, I love that. I tell you, when I saw this...
People think that's a transistor radio you've got there. No, it's not. It's a 5-tube radio with the 1 volt filaments, and it's sensitive as anything.
Like, okay, this is 19...
Like, that's transistor speed.
I just thought that's a lot. You're grown in Canada. Your night. Well, that's just beginning. It's time to dim the lights, unwind.
No, I told, and she cannot wait to tell me more rant.
88.1 FM and 690 AM in Vancouver.
Dial is a little bit off. Maybe not. Oh, I guess that's, yeah, 690, that's 7 there. Yeah, it is right. I was looking at 70, but this is 690, but it's actually on the left side of that marker, because that would be 650 down here. And there is a station there, it's just not a very strong station. It's AM 600. $730. 980 is in here somewhere. There it is. Let's turn the transmitter on and see how it sounds. Okay, my transmitter's on. I'm on 1440. So here we are. Let's put it back in the cabinet. So getting the screws back in the bottom. And put our schematic in here. I'm going to make a notation on the schematic that the tube has been replaced with a solid state rectifier. So I'm going to put on note, curtain burner cord, removed, solid state rectifier wired in. And I'm going to make a little notation here. So I'm going to do, let's see here. I'm going to run it right here. And then indicate that it's broken here off pin 8. Okay, that's how it is done. So we have now just a half wave rectifier going between the hot side. The neutral side is connected to the chassis with a polarized cord. The neutral is always connected to the chassis now, which is for safety. hot side's going into the rectifier. Then it goes into the 27 ohm resistor. And then we have our 2600 ohm resistor, which is what's dropping our 130 volts down to about 7.5 volts to power up the series string of 1 volt filament tubes. So that is our modification. This goes in the base here. Not that I'm intending on parting with this radio anytime soon, but you never know who will end up with this radio down the road. It could very well get sold. It all depends. If someone comes to me and makes me an offer that I can't refuse, then it could end up in somebody else's collection, or it may end up in my collection until I'm no longer around, and then it goes to someone else's collection. So in those cases, we want to make sure that whoever's got it knows what's been done to it. For posterity, I think maybe I will throw this curtain burner cord just in the bottom, just as a reminder to how dangerous these things were. It's not connected to anything, so it can just be put down there for history, because there's no reason to remove the back from this one now, unless someone wanted to run it off of batteries, which it still could. Now, one thing I haven't done is I haven't replaced the dial light, because I need a 6-volt dial light and I don't have a 6-volt source on the radio. So I've got a couple of options. I could like put a 120 volt little 4-watt type of a nightlight bulb in there, which I might do, and then I'll have a display that lights up, and I think that might be, I might do that. I'll put a little 4-watt bulb in there, wired across the switch, 120 volt operation. But for now, I'm happy. It works.
Season 1 scheduled to start on June 9th, and with both teams forced to sit some star players out due to...
Yeah, I'm pretty happy with this one. Hope you enjoyed this look at this old 1946 Olympic radio. Safer operation than it has ever had since it left the factory. Thanks for watching. Bye for now.